Hi, I'm Elisa and I'm responsible for the introduction, question 1A and 1C. My team and I are from group B1D. Our project focuses on analyzing survey data to assist MFC management in understanding the key factors that influence LRT passenger satisfaction. By using Excel and basic statistical methods, we identified significant trends within the data to highlight what matters most to passengers. In this presentation, we will share our main findings and how they can support efforts to improve service quality. So this is our team members. We have 6 members, which is Atira, Elisa, Najwa, Marsha, Nabiha, and Bahia. For question 1A, to check whether
Good
the
day
age
everyone, today
data
I'll be
from the
presenting the
LRT
analysis
passenger
of
survey
question 2,
follow a
which is
normal
9%
distribution. I
satisfaction with the
use
LRT
Excel to
service.
create
We'll
a
be looking
normal
at two key
probability
aspects.
plot.
First,
First,
comparing
I
satisfaction
sorted
level
all the
between
age
different
value in
facility
ascending
quality, and then
order
second
and
one
assign a
is
rank to each
analyzing
one,
whether female
which is the
passengers
sample
report
size n.
higher satisfaction
Then
than
I
male passengers.
calculated the percentile for each value using the formula n minus 0.5 divided by the total number of respondents. This percentile were converted into z-score using Excel norm.s.inv function, or if doing it manual, we can subtract the mean of the dataset from the individual data value and then divide the result by the standard deviation, which gave the expected values under a normal distribution. Then I plotted the z-score on the x-axis and the actual sorted age value on the y-axis to create a scatter plot. Since the points in the plot closely follow a straight line, it shows that the age data is approximately normally distributed.
Hi, I'm Bahia and I'll be explaining question 1B. In this question, we are asked to test whether there is a significant difference in the mean age of LRT passengers between male and female respondents. The null hypothesis means that the ages of male and female passengers are the same. The alternative hypothesis suggests that there is a difference in mean age between the genders. Based on the dataset, the mean age for female passengers is 27.49 years and the male passengers is 25.43 years. The standard deviations are approximately 6.469 and 7.175 respectively. Because we are comparing two independent groups and the variable is numerical, we use independent sample t-test. This is the calculation. I use the t-test formula and substitute the value. Next, the t-value I get is 1.581. Then I use Excel to find the p-value, which is approximately 0.118. Since the p-value is greater than 0.05, we fail to reject the null hypothesis. In conclusion, there is no statistically significant difference in the mean age between male and female LRT passengers based on this sample.
For question 1C, to calculate the sample standard deviation of the age data, we begin by finding the mean age of all respondents. This is done by adding all of the age value and dividing by the total number of respondents, which in this case is 140. Once we have the mean, we measure how far each age value is from that mean by subtracting the mean from each individual age. These differences are then squared to eliminate negative values and emphasize larger deviation. We then sum up all the squared differences and divide this total by n minus 1, where n is the sample size to account for the fact that we are working with a sample, not the entire population. Finally, we take the square root of that result to get the sample standard deviation, which tells us how spread out the age data is. Based on this dataset given, the calculated sample standard deviation of age is approximately 6.72 years. This means that on average, the ages of the respondents vary by about 6.72 years from the mean age.
Hi, I'm Najwa and I will be presenting question 1D. This question asks to calculate the probability that a randomly selected passenger from the sample falls between 23 and 25 years. Given a sample size of 140 passengers, a mean age of 26.9 years, and a standard deviation of 6.72 years. So for 23 years, the Z-score was negative 6.87, and for 25 years, it was negative 3.35. Using the standard normal distribution table, we found the cumulative probabilities for these Z-scores and determined the final probability by subtracting the two values. Therefore, the probability that the sample age between 23 and 25 years is approximately 0.04%.
Good day everyone, today I'll be presenting the analysis for question 2, which is human passenger satisfaction with the LRT service. We'll be looking at two key aspects. First, comparing satisfaction level between different facility quality, and then second one is analyzing whether female passengers report higher satisfaction than male passengers. Based on the collected data, let's begin with the comparison of facility quality. For FQ3, which refer to cleanliness and maintenance, 69 out of 140 passengers reported being satisfied. In comparison, FQ4, which covered the availability of basic amenity, showed a higher satisfaction level with 85 out of 140 passengers, indicating their approval. After performing the calculation, we found a statistically significant difference with a 90% confidence interval, ranging from negative 0.211 to negative 0.017. Since the interval does not include 0 and lies entirely below it, we can conclude that passengers are significantly more satisfied with the availability of basic amenity, which is FQ4 compared to cleanliness and maintenance FQ3. After performing the calculation, we found a statistically significant difference with a 90% confidence interval, ranging from negative 0.211 to negative 0.017. Since the interval does not include 0 and lies entirely below it, we can conclude that passengers are significantly more satisfied with the availability of basic amenity, which is FQ4 compared to cleanliness and maintenance FQ3. Based on the data, the average satisfaction score for female passenger was 3.82, while the average for male passenger was slightly lower at 3.56. From the hypothesis test, we obtained a p-value of 0.036. Since this value is below the 0.05 significance level, we have enough evidence to support the claim that female passengers are significantly more satisfied than male passengers with the LRT service.
Hi, it's me again. I'll continue the presentation with question 3a, which is hypothesis testing with related samples. In this test, I'll be using service quality and safety and security as the variables, as both variables were collected from the same group of passengers, which make them ideal for a paired sample t-test. Furthermore, these two variables also represent essential dimensions of the overall passenger experience on the LRT. So as we all know, hypothesis testing with related samples is done to test if there is a statistically significant difference between two related measurements taken from the same subjects or groups. So in this case, we just set up two hypotheses, which are null hypothesis and also alternative hypothesis. If the mean rating for both variables are the same, it means that it falls under null hypothesis, and it goes the other way around for alternative hypothesis. Firstly, we need to calculate the differences, mean of differences, and standard deviation of differences using the database given. So for the mean, it's 0.129, while for the standard deviation, we got 0.748. Secondly, we need to calculate these statistics as well as determine t-critical so that we can straight away compare both of them. For t-statistics, we got 2.041, meanwhile the t-critical would be 1.977. Since the t-statistics is higher than the t-critical, which are 2.041 and 1.977 respectively, making us reject the null hypothesis. This indicates that the difference observed is statistically significant. Therefore, I can conclude that the rating of service quality has a significant effect in the rating of safety and security.
Hi everyone, Assalamualaikum. In this part of the presentation, I'll be explaining the one-way ANOVA test that we conducted for question 3B. In this question, we were asked to choose two hypothesis tests. We selected the one-way ANOVA to find out whether passengers from different employment statuses rate LRT service quality differently. Our independent variable is employment status, which has four groups: employed, unemployed, self-employed, and student. Our dependent variable is service quality, which is based on a rating from 1 to 5. For step 1, we grouped the survey data based on employment status and then calculated the mean service quality rating for each group. So employed is 4, unemployed is 2.6, self-employed is 4.4, and students is 2.83. So we can already see that the averages are quite different, but ANOVA helps us confirm if this difference is statistically significant. Step 3, we measure the variance, the sum of squares between groups, SSB, and also SSW, which is the squares within groups. So for SSB, we obtain 12.79, and for SSW, we obtain 7.24. So step 4, we compute the F statistic. Using the SSB and SSW, we calculated the mean squares of MS between, which is 4.26, and MS within, which is 0.362. When we calculated the F statistic, we get 11.77. Step 5, we make a decision. We compared our calculated F value, 11.77, with the critical F value from the F distribution table, which was 3.10 for our degrees of freedom. Since 11.77 is greater than 3.10, we rejected the null hypothesis. And that's all from me.
Hi, I am Atira and I am responsible for question 4, A and B. So for the first part in question 4, I conducted a chi-square test of independence to test whether there is a statistically significant association between gender and travel frequency. The hypothesis to be tested is as follows. Null hypothesis, gender and travel frequency are independent, meaning there is no relationship between the two variables. Alternative hypothesis, gender and travel frequency are dependent, meaning there is a relationship between them. On the slide, I am showing the contingency table, which includes both the observed frequencies, which are the actual counts from the dataset, and also the expected frequencies. So after performing the chi-square test of independence, I obtained a degrees of freedom of 3. Chi-square test statistical value is 3.490, chi-square critical value 7.815, and lastly, p-value of 0.322. Here, the chi-square test statistics value is 3.490, which is lower than the chi-square critical value of 7.815, and the p-value 0.322 is greater than 0.05. So the final decision would be to do not reject the null hypothesis. This means there is no statistically significant association between gender and travel frequency in our dataset. Also, we can conclude that expected frequency assumption is met because all expected frequencies are more than 5. For question B, I conducted the Man with Me You test. From our dataset, the selected variables is gender and age. I wanted to test whether females are significantly younger than males. So these are the tables showing the gender, age, and the rank. At the end, I sum the rank for both female and male to compute the U statistics. The hypothesis for this test is as follows. Null hypothesis, the median age of females is equal to the median age of male, and the alternative hypothesis, the median age of females is less than the median age of males. After running the test, I obtained U statistics for population 1 is 1538.5, while U statistics for population 2 is 2461.5. Then I choose the smallest U statistics to compute Z statistics. The Z value that I got is negative 2.13. Lastly, the p-value is 0.0166. Since Z statistics equal to negative 2.13, which is lower than negative 1.645, and the p-value of 0.0166 is lower than 0.05, so we reject the null hypothesis. We conclude that females are significantly younger than males in our dataset.
For question C, we were required to conduct a non-parametric test, specifically the Kruskal-Wallis test. The hypothesis to be tested is, the null hypothesis is the distribution of satisfaction scores is the same across all education levels. The alternative hypothesis is at least one education level has a different satisfaction distribution. The table shows the breakdown of Kruskal-Wallis test. We choose to compare satisfaction with weighting areas across 3 education levels. After ranking the scores, we calculated the sum of ranks and the sample size for each group. We will use these values in the next step to calculate the H statistic. Here are the results of the Kruskal-Wallis test. The degree of freedom is 2. The calculated test statistic H is 0.029. The chi-square critical value is 5.991. Since H is smaller than the critical value, we fail to reject the null hypothesis. This means that there is no significant difference in satisfaction with weighting areas among the different education levels. That's all from us. Thank you so much.